All right, in this video we are going to talk about how to find the distance between a point and a line. So say we're given a point Q and a line L in space, and we want to compute the distance from the point to the line. By that I mean the length of the shortest line segment from the point to the line. So if I have this point Q here, right, and then I have you can think about a bunch of line segments connecting from Q to the line, and there's going to be one that is going to be the shortest possible one, have the minimum distance, and that's going to form basically that distance, right? If I think about that line segment, it's going to be perpendicular or orthogonal to this line segment, or to the line. Okay. So that's what I would do, drop that perpendicular down. That's the distance h that we want to find. The next thing that you would do is to get a point that's on the line. And that's really easy because all you need to do is plug in some value for the parameter, and 0 is normally the easiest one. And so when you plug in a 0, you're going to get this point that this vector points to. Okay, so that's the point, capital P. And then you would find the vector from P to Q, just doing terminal minus initial when you do that. All right, and so if you think about it in terms of triangle trig, I have the angle between the vector from P to Q and the direction vector for the line, right? If you think about the sine of that angle, it's going to be the opposite, which is h, that's the length that we're looking for, divided by the length of the hypotenuse, which would be the magnitude of the vector from P to Q. Okay, so just using triangle trig, we can get that height that we want to find, or that distance that we want to find, is just solving for it. We would get that it's equal to the magnitude of the vector from P to Q times the sine of the angle in between the vector from P to Q and the direction vector of the line. So that formula is okay if you know the angle, but a lot of times we will not know the angle and not really want to figure it out, especially if we have the component form. So we can rearrange this by multiplying the top sort of by the magnitude of the direction vector over itself, as long as that's not 0, which it's not going to be. And when we do that, on the top we would get the magnitude of the vector from P to Q times the magnitude of the direction vector times sine theta over the magnitude of the direction vector. And then if you recognize the top, that's just the exactly the same as the magnitude of the cross product of the vector from P to Q and the direction vector d. Okay, and so we can replace it with that. So now we don't need to know the angle in between there. We just compute this out. So this is the form that we will use. Okay. All right, so let's take a look at an example. We want to find the distance from the point Q to the line L. All right, I have that written out over here. Let's just double check that. All right, that looks good. All right, so we have this line L. And we have Q up here somewhere. First thing we need is a point P that's on the line. And the point P is just going to be 2, 2, 1, right? We can plug a 0 in for t, right? And then we would get that point, that vector, or and remember, we can think about that as pointing from 0, 0, 0 to the line. So we would know that the point 2, 2, 1 is on the line itself. All right, so next up then we would get the vector from P to Q. All right, and we can do that by doing terminal minus initial. All right, so terminal is Q, initial is P, so 1 minus 2 is negative 1. 0 minus 2 is negative 2. And 2 minus 1 is 1. Remember, we're also going to need the magnitude of that vector, so let's go ahead and do that. And when we do that, we get negative 1 squared plus negative 2 squared plus 1 squared, and that is going to come out to be 1 plus 4 plus 1. And so that comes out to be square root 6. Okay. So we have this vector from P to Q. And so now what we need to do is to cross it with the direction vector. The direction vector, right, is just this vector here that's with the t. So that's 4, negative 1, 2. Okay, and so let's go ahead and work that out, the cross product. So we have I, J, K. All right, and the vector from P to Q is minus 1, minus 2, 1. And the direction vector is 4, negative 1, 2. And let's rewrite that first column, negative 1, 4. The second column is negative 2, negative 1. All right, and then we're going to start multiplying this out. All right, so that's going to be negative 4i, right? I times negative 2 times 2. J times 1 times 4 is plus 4j. K times negative 1 times negative 1 is plus k. All right, and then going back the other way, we have, hopefully I left enough room here, negative 8k. Actually, I don't think I did. Negative 8k. And that's from here, k times negative 2 times 4. We have I times 1 times negative 1, so that's minus I. And then we have j times negative 1 times 2, that's minus 2j. And then we are going to subtract those, so it's negative 4i plus 4j plus k. So the ones on the right minus the ones on the left, so minus 8. Actually, I want to rewrite that in the standard order. So that'd be minus 1i, minus 2j, and minus 8k. All right, and working that out, I get negative 4i minus a minus I, so that's going to be minus 3i. And then 4j minus a negative 2j, so that's going to be plus 6j. And then k minus a negative 8, that's going to be plus 9k. There. All right, so we get minus 3, 6, and 9 for the cross product. So next up, we need the magnitude of that. So the magnitude of the cross product did that backwards there. Is going to be square root of negative 3 squared plus 6 squared plus 9 squared. That's going to be the square root of 9 plus 36 plus 81. Which is going to be 81 and 9 is 90. And then 90 plus 36 is 126. Okay, and so now going back to the formula that we were using, right? The formula for the distance between the point and the line, right? It's going, h is going to be equal to the magnitude of the vector from P to Q crossed with the direction vector divided by the magnitude of the direction vector itself. That's going to be Um, let's see. Magnitude of the direction vector crossed the magnitude of the vector from P to Q crossed with the direction vector is 120 square root 126, and the magnitude of the oops, I actually did that incorrectly, didn't I? It's there, so I took the wrong one, so sorry. Let's see, it's the magnitude of the direction vector that we need. So this one is good. I didn't need to do this one, but I did. All right, so the magnitude of the direction vector is the one that we need, and that is going to be 16 plus 1 plus 4, which is square root 21. Okay. All right, and so we'd have that over square root 21. Let's see, and so we'll need to reduce that if we can. 3 definitely goes into 126, so we could do this, 126 over 21. Three goes into 21 7 times. 3 will go into 126, right, 42 times. And then actually 42 sevenths is 6, right? So the answer, final answer here is the square root of 6 on this one.